Modeling, Topic 6, Section 5, Computing the VaR of a Portfolio using the at-risk software. Now, at-risk is a software that's used as an add-in in Excel. It's sold by Palisades Corporation or company. And it would allows you to automate that task of setting up that macro we did and running the 5,000 or 10,000 iterations. The flexibility of at-risk is later we're going to use at-risk to use other distributions besides the normal distribution. So what we're going to do is we're going to go to our Excel file and launch at-risk. Let's talk about how you get at-risk. If you want a 15-day free trial of the software today, we'll just go to the Palisades website and ask for the student version. If you have an EDU email, they'll generally just give it to you automatically pretty quickly. Now, those trial versions expire after 15 days. What you might want to do at some point is go ahead and purchase the student version. So let's talk about using at-risk once you have it installed on your computer. What you're going to do to make an at-risk Monte Carlo simulation, you just first need to build a financial model. And that model has to have at least one stochastic variable, say portfolio returns. When I say stochastic variable, that's one in which we're going to generate random values for. And it has to have at least one output. So you have to have one random variable and one output. We are then going to define the distribution for that random variable. In our case, we're just going to use normal distributions. We're then going to run, say, 5,000 or 10,000 random numbers, which will give me 5 or 10,000 outputs. And then what we're going to do is we're going to evaluate those 5,000 iterations or 10,000 iterations and look at things like the 5% worst case, 5% best case, confidence intervals. So I'm going to go to at-risk and download it. I'm going to launch it in Excel, and then I'm going to make some changes. First of all, let me launch at-risk. Oh, looks like I already did. I launched at-risk. Notice if you're in at-risk, or if you've launched it, you'll have an at-risk on your menu. And what I need to do now is modify my spreadsheet and tell at-risk what my stochastic variable is. The way we're going to do that today, we'll change this in the future, is I'm going to get rid of my random norm S inverse rand and replace it with an at-risk formula equals risk normal 0, 1. Now when I hit enter, it's just going to keep 0 in there. That's why I've kind of one away. However, when I run the simulation using at-risk, this is the cell that's going to change 5 or 10,000 times, whatever I specify. Then I'm going to go to this cell here and specify this is the one that I want to collect data on. It's kind of specifying that here's I want to collect 5 or 10,000 outcomes. So I'm going to click on this cell here, go up to the menu in at-risk, and click on Add Output. Hit OK. Now notice if I were to go to my model window, I should have one input, which is that random Z, and I should have one output. So now, if I go to at-risk, I can now choose, say, 10,000 iterations or 100,000 iterations. Let's just do 10,000 iterations for now. Hit Start. Well, actually, before I do that, let me click on my output, B20. 10,000, and let's go ahead and run 10,000 iterations of this portfolio value. This is the histogram that's going to be automatically generated if your cell is currently selected the output cell. And by default, what you should see is something that looks like this, where you have a 95% confidence interval, and it's saying that the 5% worst case, or sorry, the 2.5% worst case is -34, and 2.5% best case. Sometimes the default gives you the 90% confidence interval, where the 5% worst case is losing $27,900, which should be a familiar number, right? There's our $27,900 right there. So what at-risk did for me is it ran 10,000 random portfolio values using that random Z. It then automatically created a histogram, which I can then explore a little bit. So what I can do is I can grab this right confidence interval line, drag it across, and now I have a nice picture of my VaR of this portfolio. 5% of the outcomes are losing more than 27,911. 95% of the outcomes are losing less than 27,911. So this is a picture of my 95% confidence interval VaR. I could right-click, copy, graph. I could close that, and if I wanted to include this in my report, I could put this in my PowerPoint or Word document, or I'll just put it in the spreadsheet for now. Again, notice at-risk is not using this column here. It's simply running its own simulation. One other thing I wanted to show you in at-risk is one way of getting the VaR is to specify that 5% tail. By the way, how I can get back to that interactive histogram is to click on the output and hit Browse Results. If nothing's changed, I don't have to rerun it. If I wanted the 1% worst case, I can say the 1% VaR. So now my 1% VaR is 41,584. That's my 99% confidence interval VaR. Let's go back to 5%. Another thing you can do is you can say, what's the probability of losing, say, $40,000? Looks like I have a 1.2% chance of losing $40,000 or more. What's the probability of gaining $50,000? Looks like I have a 1.2% chance of gaining $50,000. So you can really change the probabilities on the right tail, or the critical value here on the right tail and on the left tail, or specify in the middle, I want the 90% confidence interval, which will give me 5% on each tail. Now, one way of getting the data like this 27,911 out of at-risk without just looking at the graph is you can use a function in at-risk called risk percentile, where I'll say risk percentile, open, then reference the output cell, comma, and then put the tail, say 5%, or in this case 1 minus the 0.95. So I'll just say minus, and I make it a minus again because the loss is always represented as a positive number. Risk percentile. I'm going to put in my output cell, B20, comma, now I'll just put in my 5%, but I'll actually say 1 minus X. And there's my 27,911. If I wanted the 99% confidence interval VaR, notice that number is 41.5, and at-risk is also telling me that the 5% worst outcome is about 41.5. To get my macro to give it to me, I have to rerun this, and that number would then also be the same value. So, in this topic, we calculated this simulated VaR using at-risk, and that completes topic 6, calculating VaR. We computed the VaR of a portfolio using a formula. We then simulated a portfolio using the GBM model, random walk model. We talked about how to use macros to create that countdown, and then we used that macro to calculate or to gather 5,000 portfolio gains or losses, and then I automated the simulation process using the at-risk software.